Hello ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be going over the basics of Lewis dot structures and the principles behind them. So make sure you're following along with your notes, and then if you have any questions, you ask tomorrow. Alright, so let's talk a little bit about Lewis dot structures and what they're used for. We talked about modeling in Unit 1, and the reason why we use models is to understand the microscopic nature of molecules, and using a process of drawing them, called Lewis dot structures, seems to be the easiest way for us to kind of do this on paper. So what you see down here and in your note packet, these three little guys, they are sort of what Lewis dot structures end up looking like when we're done. And so just be aware that that is the direction that we will be going. Alright, so something that you guys asked already. Why do molecules share electrons at all? What's the point of that? Aren't atoms already sort of stable and everything? So remember that all elements do want to be completely stable. And the most stable and unreactive elements on the periodic table are those noble gases. So, you know, things like neon and helium and xenon and things like that. Those are the most stable elements on the periodic table. And the reason that they are stable is because they have totally filled electron orbitals. So we're kind of bringing back this picture of orbital diagrams from previous units. Okay? Now remember, elements want to be stable just like the noble gases are. So that means that every other group on the periodic table that is not a noble gas is not exactly as stable. So what they will do is share their valence electrons until they have electron configurations that resemble noble gases. So flash back to what noble gas configuration looks like, basically. And that's what other elements on the periodic table are striving for. So most elements on the periodic table, especially the ones that we're going to be dealing with, follow a rule called the Octet Rule. Remember, octa means 8. And that means that they will do almost anything to get 8 valence electrons, since most noble gases have 8 valence electrons. And to prove that, I'm going to draw the orbital diagrams for both neon and for argon. Okay, so this is basically just review, and make sure you draw these also in your notes. Alright, so neon has 10 electrons, so I start filling it in like this, following my rules of orbital diagrams, and I stop there. That's the noble gas configuration for neon, so that's what the electron orbital diagram would look like for that. Now for argon, I'm going to do the same thing, so I'm going to follow my rules. Okay, keep going, making sure that I keep track of how many electrons I'm actually supposed to have here. There we go. And argon has 18 electrons. And so that is argon's electron configuration. Now, remember, I said that they have 8 valence electrons. Well, where are those valence electrons? Well, valence electrons are found in the highest energy orbitals. So for neon, that would be the 2n level, and then for argon that would be the 3n level. Notice I have 8 electrons here, and I have 8 electrons in here. And so that is the reason why most elements on the periodic table want to get 8 electrons and follow the octet rule, because noble gases follow that rule, and it makes them stable. Now there are some elements that can't get 8 electrons. I mean, think about it. You know, you have like hydrogen and lithium and beryllium, and a lot of very early elements on the periodic table can't really get 8 electrons. So what do they do to get stable? Well, they follow something called the Duet Rule. And the Duet Rule means that they want to get 2 valence electrons like helium. So remember, helium is a noble gas. Okay, it's the only noble gas that does not end in on. And it has the electron configuration and orbital diagram that looks like this, and that would be the 1s. So 1s2. Hydrogen in particular, a big one, follows the Duet Rule because it can't just gain, you know, 7 electrons or something like that. So it only has to gain 1, and it will become stable like helium is. Now, how are you supposed to remember the pattern of valence electrons? Well, actually, it's pretty easy. And so here's our pattern. It's very similar to when we said, hey, remember all those charges from the periodic table? Well, now we're looking at valence electrons. And so valence electrons and the amount of charge that things have are connected. So for hydrogen and its group, they have one valence electron. And so if you drew their orbital diagram, you'd see that. For our group 2 elements, they have 2. Just like before, we skip our transition metals. In fact, because we're dealing with molecules, whenever we draw Lewis dot structures, we won't really actually be seeing these guys at all. So, transition metals, we're going to be crossing those guys out. All right, group 13, they have 3, and then carbon's group has 4, nitrogen has 5, oxygen's group has 6, then we have 7, and then, of course, the noble gases have 8, with the exception of helium, but still, we're just going to put an 8 above it anyway. And so that's the pattern for valence electrons, and as long as you remember, hey, the noble gases want to have 8, all you've got to do is just kind of spill it all out from there. So then you have your 7, 6, 5, 4, 3, 2, and 1, going all the way down. So we will need to remember the number of valence electrons, but this is kind of an easy way of doing it, if you remember the octet rule. All right, so we're not really going to talk about these steps until we do an example, but I want you to fill them all in anyway. So there are 6 key steps when we're trying to draw the Lewis dot structure for something, and here's step 1. The first thing you have to do is figure out what your central atom is. And when we say central atom, we mean what is in the middle of your drawing. Because if you go back in your notes and you look at those 3 original sort of Lewis dot structure pictures that were on the very first slide, there's something in the middle there. And so how do we know which element goes in the middle? Well, the only way we can know that is if there is a unique element, then that has to be the central atom. When we say unique, we mean there's only one of them. Next up, we have to add up our valence electrons, which is why we need to know the pattern of 1 through 8 on the periodic table. So we have to add up all of our valence electrons from every element in the molecule, okay? And when we do that, that's the total number of electrons that we can have in our drawing. We can't have any more or any less. The next step is we use single bonds to connect the central atom to the outer atoms. So we start with single lines. You don't start by drawing, sort of double bonds or triple bonds or anything. We're only going to start with just single lines connecting them. And then after that, for step 3, it says you might be done. So you want to count your electrons and check all of your atoms and see if they have duets and octets like they're supposed to. If they don't, though, then we move on to step 4. All right, step 4. Now add electrons to your outer atoms. And then once you've done that, it says you might be done. So just like before, count your electrons and check if atoms have a duet or an octet. If not, then you move on to step 5. Step 5 now says you add electrons to your central atom. And then again, you might be done. So count your electrons and check if all atoms have a duet or octet. If not, your last resort is moving on to step 6. Step 6, our last resort, is making double bonds or triple bonds, and the way we do so is by erasing a pair of electrons from an outer atom and sharing them as a new bond. And we repeat that until we have either an octet or a duet in the place that we need it to. Okay, these are the 6 steps. Again, it'll make more sense when we actually do an example, a practical one, but make sure that you know sort of where you are as we draw our Lewis dot structures, what step we're on. Okay, so I tried to pick an example of something that's common, something that you're familiar with, but something that uses every single step. Because remember, you might be done at step 3 for some of your drawings. You might be done at step 4 or step 5, but this one will take us all the way to step 6. And so this is a 3D version of what carbon dioxide looks like. So this is kind of what it's going to end up looking like by the time we're done, okay? So step 1, you have a table with all 6 steps, and we're going to draw pictures in those boxes. So I put the step at the top just so that you could see exactly what it looks like. Figure out what the central atom is. All right, so I have CO2. That is my molecule, and I need to figure out what my central atom is. So I only have carbon, and I have oxygen in my compound here. Which one of those would be my central atom? Which one goes in the middle? Because I have 1 carbon and I have 2 oxygens. So which one must go in the middle? Well, remember, I'm looking for a unique element. So in this case, the unique element is carbon. So I know carbon is going to be in the middle, and I'm going to have 2 oxygens sort of around that. That's step 1, just figuring out what's in the middle. All right, so in our second step, we need to add up our valence electrons from all of the elements in our molecule. All right, so I have 1 carbon and I have 2 oxygens, so I need to look at my periodic table and see how many valence electrons each of those elements has. So take a look. Carbon has 4 valence electrons, and oxygen has 6. And I have 2 oxygens, so I actually have 12 from the oxygens alone. So what is 12 plus 14? I have 16 electrons in my drawing, and I shouldn't have any more than 16. Okay, that's sort of my barrier there. I can't have any more or less than 16. Right, so as a little reminder, I put 16 over there and I circled it because I have to have 16 electrons. So step 3, use single bonds to connect the central atom to the outer atom. So that means I just use single lines like that. All right, it says, you might be done, count your electrons, and check if all atoms have a duet or octet. If not, move on to step 4. All right, so here's the thing. Each line that you have in your drawing, so I'm just going to bold these. I'm not drawing a second line, I'm just bolding them. That line represents 2 electrons, because in order to create a covalent bond, you have to share electrons, and so the minimum amount of electrons you have to share are 2. So every time you see a line connecting 2 elements together, that would be an example of a single bond. And so single bonds have 2 electrons. So right now in my drawing, I only have 2 bonds, and that's 2 electrons apiece. I only have 4 electrons total in my drawing right now. So there's no way I'm done, because I have to have 16 electrons in my picture. So I have to move on to step 4. All right, so what does step 4 say? Add electrons to the outer atoms. You might be done. Count your electrons. All right, so remember, every element wants to have 8 electrons. I can't have any more than 8 electrons around something. When it says I add my electrons to the outer atoms, it's talking about these guys. These are my outer atoms, whereas carbon is my central atom. So I start by adding my electrons to the outside atoms first. Now, how do I add those electrons? It doesn't technically matter, but I can't have any more than 8. And so remember, each bond counts as 2. So I'm going to start on the left-hand side. So right now I have 4 electrons in my picture, 2 from this single bond and 2 from that single bond. So I start adding. So I now have 4 electrons in my picture. I have 5 electrons, 6, 7, 8, 9, 10. Why do I stop there? Well, look at my picture and my left oxygen. It has 8 electrons around it. That single bond counts as 2 electrons. So now I keep adding them. We're going to move on to my next oxygen. I have 11, 12, 13, 14, 15, 16. All right, so it says I might be done. So I have to look, count my electrons. Good, I have 16 electrons just like I want in my picture. It says check and see if all atoms have a duet or an octet. So let's count my electrons around things. Right here, this guy has 8 electrons. It has an octet. It's nice and happy. This guy right here has 8 electrons around it. It has an octet. It's happy. What doesn't have an octet? Well, carbon. Carbon only has 4 electrons around it. In case you're wondering, you're like, wait a second, I thought we counted those electrons as being part of oxygen. Remember, those bonds, they're sharing their electrons. So carbon gets those electrons part of the time. Oxygen gets those electrons part of the time. So right now, carbon only has 4. So I can't stop. I have to move on to the next step. All right, so step 5, add electrons to the central atom. You might be done. Count your electrons. All right, well, here's the thing. If I start adding more dots, so don't start drawing this, by the way, because I'm doing this incorrectly. But let's say I start adding dots like this. And then I'd say, well, wait, now everything has 8. I'm done. If you count your electrons, though, I now have 20 electrons in my picture. And I'm limited. I can't have any more than 16. So in reality, I can't add electrons to my central atom. I'm stuck right here. I can only have 16. So my central atom can't gain any more electrons. I'm stuck. So count your electrons and check. I'm still in the same boat. This guy still has 8 electrons. This guy still has 8 electrons. But my carbon only has 4. So I need to move on to step 6. Alright, so now we're in our very last step, and this is the way it looked when we were on step 5. So it says make a double or a triple bond by erasing a pair of electrons from an outer atom and sharing them as a new bond. Okay, so how do I go about doing that? It doesn't matter which pair of electrons I erase. I can erase any pair of electrons from any outer atom I would like. And so if you take a look at our left oxygen, I'm going to erase these two bottom electrons, and then I make this now a double bond. And so I have two lines now on the left side. Now, why am I able to do that? It's because I'm not gaining any extra electrons by making a double bond. I'm moving electrons from being only on the oxygen to now being shared between the carbon and the oxygen. And so right now, carbon now has 6 electrons around it. So I can do the same thing with the opposite side and erase another pair of electrons. And now I have another double bond on the opposite side. Now, how does this fix our problem? I didn't gain any extra electrons by doing this process of making double or triple bonds. All I did was move electrons from being solely, exclusively part of oxygen to now being shared between oxygen and carbon. So now I have 8 electrons around my oxygen here still. I have 8 electrons around my oxygen here still. Remember, each line represents 2 electrons. So I technically have 8 electrons around both of my oxygens. And now I also have 8 electrons around my carbon in the center. Now remember, this is our last resort. This is step 6. This is the final step, your very last thing you could possibly do to get this to work. And so don't start by trying to draw in some double or triple bonds. If you do this too early, you will almost always get the wrong answer. So make sure you follow these steps sequentially. Remember, along the way, in step 3, it said you might be done. So in some Lewis dot structures, you might stop at step 3 and be totally and completely done with everything. In step 4, you might be done. In step 5, you might be done. Definitely by step 6, though, you will be done. Okay, but it is, again, our very final step, so make sure that you don't just try to, just draw in some double or triple bonds without thinking about it. It should be like the very last thing you do, if you have to. Alright, and so our last example that we're going to do is for the molecule H2S. And so just like before, I'm going to go through all my steps. So step 1, find the central atom. I only have H's and I have a sulfur. So since sulfur is my unique atom, that's the one that's going to go in the center. So I would have sulfur in the middle, and I would have 2 hydrogens on the outside. For step 2, I have to add up my valence electrons, so I need to look at my periodic table. So if I look at hydrogen, hydrogen has 1 valence electron, but I have H2S, so I have 2 hydrogens. And then if I look up sulfur, that has 6. So when I add all of those together, I have 8 valence electrons in H2S. Alright, so to remind us that we have 8 electrons, I put an 8 in the corner. I use single bonds to connect my central atom to the outer atoms. And remember, I just use a single line. Each line represents 2 electrons. So it says you might be done, so count your electrons. Alright, so remember, hydrogen wants a duet. It is the only element that we're going to be using in compounds that only wants to have 2 electrons associated with it. So right now, technically, hydrogen has a duet in both situations. This hydrogen has a duet, and this hydrogen has a duet. The big problem here is, of course, that sulfur follows the octet rule, and it only has 4. So I need to move on to step 4. So what does step 4 say? Add electrons to your outer atoms. You might be done. Okay, so again, hydrogen is fine with 2 electrons, and it has that. So you will never, and please don't draw this in because this would be incorrect, you'll never see hydrogen surrounded by electrons like this or like this. That is considered extremely incorrect because hydrogen doesn't want to have more than 2 electrons, so it cannot possibly have an octet. Okay? So because I can't add any electrons to my outer atoms, my 2 hydrogens, I have to move on to step 5 because I still don't have 8 electrons in my picture. I only have 4. I have 2 from this bond and I have 2 from that bond. So I'm still missing 4 electrons. Alright, so step 5, add electrons to your central atom. You might be done. Count your electrons and check and see if we have a duet or an octet in all cases. So I still need to put 4 electrons somewhere, and I can put those electrons on my central atom like this. Now I have 8 electrons in my picture, and I need to check and see if I'm done. So hydrogen has 2 electrons around it. This hydrogen has 2 electrons around it. My sulfur has 8 electrons around it. So technically, I'm done. I don't need to make any double bonds. I don't need to make any triple bonds. If I would have done that, especially early on, I would have been totally and completely incorrect. So remember, step 6 is there as our last resort. If we don't have to use it, we can stop at any other step along the way. So I might stop at step 3, step 4, or step 5. If, all else fails, I have to move on to step 6. In this situation, I'm done. So what are you going to do next? Well, I'd like you to attempt to draw the Lewis dot structures for the following molecules. Notice that they give you their names. So yes, you still have to remember from our last unit how to name compounds, so you have to be able to write their formulas down. Some of them, though, like these two, I just gave you their formulas because they're just some kind of strange names or something that you wouldn't probably be able to think up off the top of your head. All right, so if you are having difficulty with these, obviously, I'm assuming you will, bring your questions, specific questions, tomorrow to class. So please don't just say, I don't get letter A. Tell me what step you're stuck on, whether or not you're sure how the steps even work. I need specific questions, okay? So make sure that you are as specific as you possibly can be. And if you want to check your answers, though, here's a great resource. All right, so this is Wolfram Alpha. They have a Lewis dot structure generator, and so all you do is you type in the formula, and it will give you the Lewis dot structure. Now, it gives you a lot more information than just the picture. Sometimes you'll see like pluses or minuses or something like that. They're giving you information that we're not even going to really talk about, which is called formal charge. So if you see pluses or minuses or something like that, you can just ignore those. But it will give you the actual number of bonds. It'll give you the dots and kind of where they go and all of that. And so they give you at least an idea of whether or not you're doing these correctly. There will be a link to this on Google Classroom for you to use, and just make sure that you use it as a good resource for checking your answers.